Now let's discuss about the ancient astronomy and modern astronomy. I already told you that the ancient astronomy known to be that of Mesopotamian astronomy or Babylonian astronomy, mainly from 3500 to 3200 BC. And this Mesopotamian civilization or Babylonian civilization is the civilization who started studying this astronomy. The first civilization known to possess a functional theory of planets is the Mesopotamian civilization. By the 6th century, people in the Greek understood the value of for reading the stars as an aid to navigation. So during that time itself, the Greek people were use the stars as for their location during the navigation. Now let's discuss some of the main contributors to the astronomy, especially the ancient astronomy, that means before 1600s. During the 1600s, the Galileo introduced the telescope, and Kepler introduced the Kepler's laws of planetary motion, and later Newton proposed the law of gravitation, etc. started the actual scientific understanding of this field. So we will discuss here the people who made remarkable contribution to the astronomy before the discovery of the Galileo's telescope. So first one is the Thales. He successfully predicted an eclipse in 585 BC. He is credited with inventing trigonometry, apparent diameter of the sun. Another contributor is the Anaximander, the first Greek philosopher to create a cosmological model. He imagined that Earth is hanging in space and other heavenly bodies encircling it. Also, he assumed that Earth was cylindrical. All his assumptions are wrong, but the observations what he has just observed with his naked eye has been recorded. That's why he has used the Earth is hanging in the space, and all heavenly bodies or the celestial objects are revolving around this Earth, which is called the geocentric model. So Anaximander first introduced the geocentric model. After that, the Pythagoras, during the 572 to 492 BC, postulated Earth was spherical. Anaximander introduced that the Earth is cylindrical, but Pythagoras postulated that Earth was spherical. Then Plato suggested that sun, stars and moon were fixed to concentric crystalline spheres rotating inside one another. That sphere nowadays we are calling it as the celestial sphere. But we know that these sun, stars and moon are not in a concentric crystalline spheres. After that, the Aristarchus, who made the reasonable estimate of the distance of the sun and moon from Earth. It's not exact, but a reasonable estimate of this distance of the sun from Earth and moon from Earth is made by Aristarchus. He is actually suggested the first who suggested the heliocentric system, that is, sun was at the center and the planets are revolving around the sun. Later, in the 2nd century BC, Hipparchus explained how the moon and planets varied in size and brightness. As we know that the reason for varying brightness is due to the distance and The size is also, variation in the size is also due to the distance of the object from the earth. That is first explained by Hipparchus during the 2nd century BC. Then Ptolemy made a geometric representation of the solar system that predicted the positions of the planets for any desired date and time. He used geocentric system. It's a wrong thing, but with reference to this geocentric system, he could predict the position of the planets for any desired date and time. So these are some of the people who made major contributions to the ancient astronomy. Then after comes the modern astronomy. The events that brought astronomy to the state of modern science are two. One is the introduction of the heliocentric system, and another one is the invention of the telescope around 1600s. So the first one, the foundation for the modern astronomy lies in the fact that all planets and the comets are revolving round the sun, and the sun is at the center, which is called the heliocentric system, which was first suggested by Aristarchus, but it is established by Nicolaus Copernicus. So the credit to this heliocentric system goes to Nicolaus Copernicus. He introduced and he established this heliocentric system in 1543, and he assumed the orbit to be circular, even though it is wrong understanding that the orbit of the planets are, we know nowadays, we know that they are in orbit, in elliptical orbits, but Nicolaus Copernicus first established the heliocentric system. That means all planets are revolving around the sun, with sun at the center of this system, solar system. And then later Tycho Brahe proposed a hybrid model of moon and sun orbiting the earth and other planets moving round the sun. This is also a discarded one, but Tycho Brahe introduced a proposed a hybrid model of moon and sun. The moon and sun is orbiting round the earth and other planets are moving round the sun. Then after, German astronomer Johannes Kepler, he lived from 1571 to 1630, used Brahe's, that is Tycho Brahe's Mars observation to establish that planets moves on elliptical orbit around the sun, and derived his 3 laws of planetary motion. That is the importance of Tycho Brahe. Using the Mars observations of Tycho Brahe, Kepler established the planets are moving in the elliptical orbit. So the first theory or laws regarding the modern astronomy is put forward by Johannes Kepler, and they are named under 3 laws. The first law is called the law of orbits, that states that every planet revolves round the sun with the sun at one of the foci. That is, every planet revolves round the sun in an elliptical orbit with one sun at one of the foci. The second law is called the law of area. It actually, simply we can say that the radius vector is a constant. Radius vector is the vector drawn from the sun to the planet. An arrow drawn from the sun to the planet, and if we call it as a radius vector, then the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. That is the second law. That is, we can say that aerial velocity of the planet is always a constant. Sorry for radius vector is not constant. The radius vector, the drawn from the sun to the planet, sweeps out equal areas in equal intervals of time. That means the aerial velocity is a constant. So that is the second law of Kepler. The third law is law of periods. That is, the square of the time period of the planet is proportional to the cube of the semi-major axis. That usually we will written like this: t square, the period square of the period of a planet is proportional to the cube of the semi-major axis. T square proportional to a cube. That is the third law. So these are the three laws put forward by the Kepler. It is actually from the observations of his ancestors, especially from Copernicus, from Tycho Brahe, from Hipparchus. He used all the previous observations to formulate these three laws. Again, I am mentioning these three laws once again. First one is the law of orbit. Every planet revolves round the sun in an elliptical orbit with sun at one of the foci. This is the law of orbit, or the first law of Kepler's first law of planetary motion. The second law is that the aerial velocity is a constant. That means it is called the law of area. The aerial velocity means the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. So if you consider a elliptical orbit like this, suppose sun is at this position, then if you take the time to move from A to B is dt, then in the same time t dt, the planet will cover this distance A prime B prime. Now if you measure this area, that is area within this region A prime S B prime, and area within this one, that is B S A, this will be equal. These two areas, these two shaded areas will be equal if the time taken by the planet to move from A to B is same as the time taken by the same planet to move from A prime to B prime. So this is called aerial velocity, constancy of aerial velocity of a planet. The third law is the law of period. It states that square of the time period of a planet is proportional to this cube of the semi-major axis. So these three laws are the first, or the founderstone laws of the astronomy or modern astronomy. Now later, the Galileo Galilei gave the evidence for the heliocentric model with his telescope discoveries of the moons of Jupiter and the phases of Venus. From the moons of the Jupiter and the phases of Venus, he could establish the heliocentric model, and to observe these moons of the Jupiter and the different phases of Venus, we need a telescope, and Galileo Galilei was the first man who constructed a telescope. With his telescope, Galileo discovered 4 bright satellites of Jupiter, the phases of Venus, mountains on the moons, spots on the sun, and rings of the Saturn. Also found M44 cluster of stars. Then after, by using the Kepler's laws of planetary motion and Galileo's observations on the its different aspects like the moons of Jupiter, the phases of Venus, the mountains on the moon, and the spots of the sun, etc. Newton formulated the actual celestial mechanics. Means the theories regarding the motion of the planets around the sun is called celestial mechanics, which actually began with the Newton's law of gravitation. And you are all familiar with Newton's law of gravitation. That is, mathematically we can write it like this: F is equal to G m1 m2 by r square, where m1 m2 are the two masses separated by a distance r, will be having an attractive force, and that force is called gravitational force, and its magnitude is given by F is equal to G m1 m2 by r square, where G is called the universal gravitational constant, whose value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Newton's law of gravitation, I think all are familiar with it. Anyway, for recalling, I'm stating it again. The force of attraction between any two masses m1 and m2 separated by a distance r is proportional to the product of the masses and inversely proportional to the square of the distance between them. If m1 and m2 are the masses of the two objects and r is the distance between them, then the gravitational force between these two masses m1 and m2 separated by a distance r is given by F is equal to G m1 m2 by r square, where G is called the universal gravitational constant, whose value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. As an end to this chapter, let's just mention something about the Indian astronomy, the contributions of the Indian astronomers to the astronomy. Indian astronomy has a long history stretching from prehistoric to modern times. Sources of the earliest roots of Indian astronomy can be dated to the period of Indus Valley civilization or earlier. That means we can say that Indian astronomers made contributions to the ancient astronomy as well as to the modern astronomy. Indian astronomy was influenced by the Greek astronomy beginning in the 4th century BC itself. Indian astronomy actually flowered in the 5th and 6th century with Aryabhatta. Later, the Indian astronomy is significantly influenced by Muslim astronomy, or call it as the Arabian astronomy, the Chinese astronomy, and the European astronomy and others. So actually we can say that the Indian astronomy actually began with 4th BC and it flowered in the 5th and 6th century with Aryabhatta. Aryabhatta is actually from BC 476 to 550. Aryabhatta explicitly mentioned that the earth rotates about its axis. Also suggested that the earth was a sphere containing circumference of around 39,967 kilometers. But we know that the radius of earth is now 6,400 kilometers. Also mentioned that reflected sunlight is the cause behind the shining of the moon. That is the remarkable contribution by the Aryabhatta, that is the shining of the moon is not due to itself, but it is due to the reflected sunlight from the moon. Also, he successfully calculated many astronomical constants such as period of the planets, times of solar and lunar eclipses, and the instantaneous motion of the moon. Another person is the Brahmagupta, who dealt with the Indian mathematics and astronomy, calculated instantaneous motion of the planets, gave correct equations for parallax. Some information about the computation of eclipses are also provided by Brahmagupta. Now, another lot of people, Varahamihira, Bhaskara 1, Bhaskara 2, Mahendra Suri, Neelakandan Somayani, and Pisarati were some of them who made contributions to the Indian astronomy. But the Emperor Shunga period was known as the golden age of Indian astronomy. During that period, the Shunga period, the star catalogue were produced. So, lot of things regarding this in the contribution to the astronomy by the Indians can be seen in many articles. So you can search for it, and also you can have a comparison with the Indian astronomy and Western astronomy. And I am not discussed Western astronomy here. As an assignment to you, I am giving an assignment to you that write a note on the Western astronomy, and just have a comparison between the Indian astronomy and Western astronomy. So at the end of this first chapter, that is introduction to the astronomy, I am giving you an assignment or a work that write a brief note on the Western astronomy and have a comparison between the Indian astronomy and Western astronomy. Thank you.